Hello, everybody, and welcome to Chapter 3. Wow, we're moving steadily along. Well, we have a really action-packed lesson this week. Look at all the good stuff we're going to be covering. Feel free to pause and take a look at our different topics. If you want to go ahead and take some notes, create an outline, and this will also be a good time to go and download the video lesson worksheet so you can work along with me throughout this lesson. Alright, you're back. Let's go ahead and get started. You're going to be working with both strings, which are alphanumeric characters, as well as numeric data. The difference between the two is that with string data, you use it for display comparisons, and then with numeric data, we use that to perform calculations, as well as make comparisons. So let's get started. If you want to use read in strings from the keyboard, and display strings and do some pulling characters and special characters from strings, then you want to use the string library. So after you include IOStream, you also want to include the string class. To declare a string variable, you're going to use the string data type followed by your variable name. Here's an example. So description is a variable name for a string. Now, when you're reading a string from a keyboard, there's two rules of thumb. If you're reading in a single word, no spaces, you can use the CN and the extraction operator, which is your right angle brackets. And here's an example of reading in a single word description. If you want to read in a phrase or a sentence or multiple strings separated by tabs or spaces, then you would use the getLine function. So it's getLine and in parentheses CN, comma, and the name of your string variable. Here's an example of reading in a multi-word string for description. Did I go too fast? Let me go back and give you guys a snap of this. Okay, another way to work with strings is with character arrays. And back in the day, we called it C strings. And this was the only way to work with strings prior to the string header library. To declare character array, you start with the data type, which is char, the name of the variable, and then in square brackets, you specify the number of characters. So say, for example, I want to create a variable that is going to, that will be able to store any of these phrases. First, I look and see, well, how many characters is the longest string there. It's about 34 characters for the Betty Smith School of Architecture. And you always add 1 to the maximum number of characters, because at the end here, what we don't see before the quote is what we call the end of the string character, or the null string. So it's not seen, but it is there to let us know that this is the end of the string. So you take the maximum, which here is 34, add 1 to it, and that will be your number of characters that you will store. If you made it 34, that means that this longest string here, we would only see Betty Smith School of Architecture with no E. Now, reading it from the keyboard, a character array, is the same thing as with the string. CN with the right angle brackets or the extraction operator. Multiple words. The getLine function is still in play, but it's not getLine all by itself. You start with CN dot getLine, in parentheses the name of the variable, comma, the number of characters. So here it's 35. So this is how we could read multiple words into the business name character array. Now, when you're working with input, there is a shortcut way to read multiple inputs from the keyboard. It's not a good way for a user because the user may not know or remember, what they're inputting. But this is allowable in C++. CN, angle, variable name 1, and so forth. So you can read in multiple variables with a single statement. It's not a good way to do it, but it is acceptable by C++. So in terms of syntax, we can do this. But the question is, will the user know what to input in a particular order? The best way to do it is to prompt the user so they know exactly what to enter. But the first one is acceptable by C++, just not for interactive programs. Here is a very interesting preprocessor directive. It's in your book because you will see it in upcoming programs. But this is something that we do not customarily use anymore in the current versions of C++. You would use pound to find the name of your constant and then the value you assign to it. Now you're probably saying, how is this different from using the const? The difference between the two is that with const data type variable, we are reserving space in memory for that constant variable. And then we put a lock on it so that nothing can change the value. Here, the constant name is not a variable. It's just a placeholder, a substitution. So instead of walking around and referring to the actual value, we can just walk around and refer to the value as this name. And this is actually done after your preprocessor directives, pound include. You will use this one between your pound includes and your int main. So here we have pound define size. Size is representing 12. So instead of typing 12 in our program, we can just say size. And so whenever the compiler sees size, it knows to replace it with the value of 12. And once again, the difference is a const is going to reserve space in memory, and a defined is just a placeholder, just a text substitution. It just makes it readable where you know what it actually means. So we're talking about size versus just the constant value 12. But this is the way that we prefer. Oops, I forgot my data type there. Shame on me. Let me get out of there. You don't need to see that. All right. Now I'm going to talk about math expressions. We have some very special operators here. Now, these are very familiar to you guys, especially from your math and algebra classes. Please excuse my dear Aunt Sally. Our compiler will pretty much follow the same order of operations that we follow in math. So we have our parentheses for grouping. Multiplication is the star or asterisk or shift 8. The slash, / is your division. We have exponents is a little different in C++, and I will talk about that shortly. Modulus, that's a very interesting operator. It's division, but instead of returning the quotient, it returns the remainder. Then we have our addition, the minus sign for our subtraction. So if you had this particular expression and we said to evaluate it, well, you're going to follow the order of operations. So the first thing we're going to do is evaluate 17 modulus 3. So that is 17 divided by 3. And what's the remainder? The remainder is 2. Because 17 divided by 3 is 5. And that's 17 minus 15. Give a remainder of 2. Then we evaluate 6 plus 2. And then 8 minus 2. So the answer is 6. The reason why I'm spending time discussing this is because you need to be able to perform these calculations to predict what your desired output is going to be. We cannot just rely on our computer program to yield the results for us. Because if we create the wrong expression and get the undesired result, then Houston, we have a problem. So we want to avoid that. Now, when we are working with math expressions, the way we see expressions is not the way C++ does. So in our eyes, if we see 12x, we know that's 12 times the value of x. C++ does not. So we have to actually specify the multiplication by using the star symbol. So here is a trinomial being assigned to the variable z. We have to specify that we're multiplying 5 by x, multiplying 14 by y, multiplying 6 by k. And it didn't come out right, but this should have been an exponent. Should have been x to the 4th. And x to the 4th, we do not have an exponent symbol in C++. So here we just multiply it all out, because that is what exponent is, repeated multiplication. Are there other ways? Absolutely. But this is the quickest way to deal with that one. Another way is using the CMath library. We can use the POW function. So that's POW and the base, which is x, comma 4. So that's another way to work with exponents. And once again, in order to use this function, we have to include the CMath library. So here we have a division problem. Well, we don't have a horizontal bar in C++, so we group the numerator, h plus 12, divided by the grouping of the denominator, 4 times k. Here I could use the POW, but I chose here to just do the multiplication. And here is how it looks with the POW function. And either of these will be acceptable in C++. Once again, feel free to pause whenever you need to, so that you can, absorb this wealth of information. Assume a program has the following variable definitions. Int a, and b is initialized to 2. we have double C assigned 4.3. And we have these statements. A equals B times C. What will be stored in A? Well, you have 2 times 4.3, which is 8.6. But since A is an integer, it's not going to store 8.6. It's just going to store the integer portion, which is the 8. So A will store 8 and not the 0.6 because A can only store an integer value. So the 0.6 will be removed or truncated. Typecasting. Sometimes, if we go back to this one, what if you wanted to use 8.6 and not the integer portion 8? Well, you can typecast it. And typecasting is where you have a variable, like for example an integer, but you want to use it as if it was a double. But you still want to keep the original variable as is. Then you can do a typecast where it temporarily changes the data type of a variable. Here's the syntax to typecast a variable. So here's the variable called variable name. The syntax is static underscore cast. In angle brackets, whatever your data type is. And remember, this is a temporary change. So you can static cast a variable. You can static cast a value. You can static cast the results of an expression. So if I wanted to display 14.7 as an integer, I can cout static cast, the data type is int, and then the num value is 14.7 enclosed in parentheses. That is the syntax that you would use. So then 14 is now displayed. You're probably asking, oh, would it round it up? It does not. It only takes the integer portion of the number. Let's go ahead, and one of the reasons why this is so useful and powerful is because if you're dividing two integers, you're going to get an integer answer. The quotient is just the integer. It doesn't give us a decimal if there is a decimal. So, but if you want to force it to have a decimal, then you would typecast it as a double. So we have double quotient. We have two integers, A and B. The values are 8 and 5 respectively. And if I would have just done A divided by B, A divided by 5, I would just be 1 because the two numbers are integers. And so quotient will only store 1 even though quotient is a double. Because the right side is evaluated first. And then its result is then stored into the left side. So because there's integer division, gives us an integer quotient, we're left with an integer answer. But if we static cast A, you could also static cast B, even though it's harder to read. That's going to turn 8 into 8.0. And by one of them being a double, it's going to give us a double result. So instead of returning 1 and storing in quotient, quotient is going to now store the value 1.8. You are accustomed to this assignment statement, x equals x plus 1. Well, that's the same as this combined assignment statement, x plus equals 1. This is a shortcut that we can actually use in C++. The reason why I'm showing it to you is even if you write complete assignment statements like the first one here, you will see this one used interchangeably throughout programs. These are the ones that you can use as combined assignment statements. So the first one would be x equals x plus 1. The second, that would be read as x equals x minus 1. X equals x times 1. x equals x divided by 1, x equals x modulus 1. Here's another example. Score equals score times 19. That can also be read as score times equals 19. Like I said, it's a nice little shortcut that basically performs the same job as this complete assignment statement. Here's another one. A equals a minus 7. Oops, that should be 17. Sorry. Let me see if I can do a quick edit and I'll be right back. There we go. I feel so much better. So a equals a minus 17 is the same as a minus equals 17. It is a good idea just to make up some of these and translate them to the other side and vice versa. Alright, another very interesting statement that we can do in C++ is a multiple assignment statement. So if you know that multiple variables are going to be storing the same initial value, you can just write them all up in one statement. I know it's very interesting, isn't it? So it always starts from the right. So 19 is going to be assigned to the variable to its left. And so that means that varname 3 equals varname 4. We go to the right. So varname 4 having a value of 19 is going, that value of 19 is now going to store into varname 3. 19 from varname 3 is going to store into varname 2. The value stored in varname 2, which is 19, is now going to store into varname 1. Isn't that just delightful? So that single statement, is identical to these 4 individual assignment statements. And this is allowable in C++. Is it advisable to do this? I would say use it very carefully because it's very hard to read and debug if you're trying to track what could be going wrong with some of your problems. Alright, hand tracing. Now that you guys understand how to read from a keyboard, display strings and characters and variables, and do some calculations and display the results, you guys are going to start embarking on more complicated programs. And when you're working with a plethora of variables, you need to be able to keep track of what values are stored in them, from one statement to the next. Hand tracing is an invaluable skill set. You have to know how to read the code and trace your variables at any given time. So here's an example program. We have 4 variables. We're entering the data. We're performing a calculation and then displaying the result. So here is a hand tracing table. This is something that I use a lot even to this day. So say for example, we start off with these first 2 statements, N1, N2, N3, and A1. They have been declared, and then we prompt the user to enter a number. Well, we don't have values for them, so we use question marks. So say for example, we go ahead and we input 5 for N1. So I'll go ahead and log the value for N1, which is 5. And then we still don't have values for N2, N3, or A1 yet, until we prompt and get the value for N2 here. So in doing so, N2 has a value of 3. And then we prompt and get a value for N3 has a value of 4. Then we perform our calculation, and the average is, coincidentally, happens to be 4 for A1. Then we display. So So this way you always know what the values are. And so whenever you see a reference to a variable, you know to go back to your table to find out what the value is. And that's a hand tracing table. Invaluable skill. All right. Another skill set that we need to have is formatting our output. And we have some very colorful strategies for doing that. Let's take a look at this one. We have 3 variables. We have A, B, and C. The values are 5, 3, and 2 respectively. And we're displaying the values on the screen. So this is what we'll see on the screen based on our cout statement. Notice that 5, 3, and 2 are together, and it looks like to us 532. But is that really what our intent was? The answer is likely no. So a way to work around that so that we can display our numbers, and where they have like some spaces in between, we can include a new library called IOmanip. And it has a very special function called setW, which stands for set column width. So if we place the setW followed by an integer value, then there's going to be a width here of 5 spaces dedicated to just this variable. Then the next one's going to have 5 spaces. The next one will be 5 spaces. If you're familiar with setting up tables in Word or creating Excel spreadsheets where you have columns of data, you usually, you can set the widths of your columns or even the heights of your rows. But we can't do the height of the rows, but we can definitely do the columns in C++. This is where we get a chance to set those widths of each of those columns in C++ here. So now we have some space here. So notice here that just assume there's 5 spaces here. So we have like nice columns for our numbers. So they're lined up very nicely. First is all bunched up together because we didn't give it any spaces. Next argument is, well, can I just put like what double quote, space, 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 close double quote? That will be great if you're just working with single digit numbers here. But if you end up working with 2-digit numbers or 3 or 4-digit numbers, then your spaces, the values will not be lined up in nice columns. Instead, they'll be like skewed, especially if you end up having multiple, rows of data. They won't be lined up in a tabular format. So that's one of the benefits of using setW and then your integer value, which is the width. Now another thing is sometimes we want to just, format and control how our decimal numbers appear on the screen. And we will use the IOmanip to do that. So here we have a double. It has a value of 2637.238394. I want to limit the number of decimals to 4 instead of 6. Well, I can use the fix, that's another keyword that comes from IOmanip, and set precision, and then an integer value. So here it's 4. So instead of giving me all 6 decimals, it just gives me 4 according to this setting. And notice that it also rounds it up. So this is a very smart function that doesn't just take 2383. It actually acknowledges that there's the 9th there, and it rounds it up for us. And that's how fixed set precision works. Can you use set precision all by itself? Yes, but if you want to guarantee your output, then you want to use fixed and then set precision. Oh, right. Now here are the two players that I introduced you to in today's class. We use CMath for math functions. So things like power for exponents, absolute value, square root. We also have trig functions like sine, cosine, tangent. And then we have output, where we have fixed, set W, and set precision. These are some very powerful players here. Now let's go ahead and design a program. This is the favorite part of the lesson for me. So Little Italy Pizza charges $12 for a 12-inch diameter sausage pizza and $14 for a 14-inch diameter sausage pizza. Write the pseudocode algorithm that calculates and displays how much each of these earns the establishment per square inch of pizza sold. The hint is that you'll need to first calculate how many square inches there are on each pizza. Okay, so first thing, you're going to analyze it and find out what's your inputs and what's your outputs and what are some of the processings that you need. But you know that I really truly love algorithms. So like it says here, I need to find out how many square inches are on each pizza. So I have a variable for square inch for the 12-inch, square inch for the 14. Then I want to know how much the 12-inch cost, how much the 14-inch cost. And I have a constant, inch 12. It's going to cost $12. I have another constant called inch 14 for $14. And I'm going to use those to help me find the cost for each of those pizzas. Do you have to do this? No, but it makes it really good for accountability. And also, say for example, they say, well, instead let's change it from 12 inches to 16 and change the 14 to 20. I know those are magnificent pizzas. Instead of going in and changing it all in your code, you just come to the constant line and change it there that one time. So here's how I'm calculating the number of square inches for 12-inch pizza. Here's my pi. I could have done 22 over 7 also, but I'll keep it simple. Here's my radius, 12 inch divided by 2 times 12 inch divided by 2. Could you have done the power function? Absolutely. Did the same thing for the 14-inch. So the cost per 12-inch, take the $12 divided by the square inch total that we calculated here to get the cost for a 12-inch pizza. Do the same thing for a 14. And then we display the results for the 14-inch pizza and the 12-inch pizza. Isn't that fun? And then we're done with the program. Take a screenshot of this because in the next video, we're going to actually type the program and make it run. And guys, that's it for chapter 3. Enjoy, and I look forward to seeing your post in the threads. Have a great one.